So here are the questions on algebra, and the first section from May 2010 asks us to solve some equations. So the first one is 8x equals 56. Simply dividing both sides of that by 8, we get x equals 7. The second one is 48 equals 3x plus 12. Now first of all, we'd like to get the x bit on its own, so we need to take away the 12 from both sides. So doing that, we get 36 equals 3x, but we don't want to know what 3x's are, we want to know what 1x is on its own. So we divide both sides by 3 to get x equals 12. The next one is a bit trickier because we've got x's on both sides. We've got 10 plus 4x equals 2x plus 20. We'd like there to only be x's on one side, so we want to take away as much x as we possibly can from both sides. So we've got 4x's on the left and 2x's on the right, so the most x that we can take away from both sides is 2x. So we take away 2x from both sides, and we get 10 plus 2x equals 20. Now we'd like the x bit on its own, so we want to get rid of the 10, so we take away 10 from both sides and get 2x equals 10, but we don't want to know what 2x's are, we want to know what 1x is on its own, so we divide everything by 2 both sides and we get x equals 5. The next block is from December 2010. Solve the equations, and the first one is 3x minus 6 equals 30. Now we'd like the 3x bit to be on its own, so we want to get rid of minus 6. To get rid of minus 6, we add 6 to both sides, and when we do that, the minus 6 disappears, and on the right hand side we get 36 from adding 6 to 30. So 3x equals 36, but we don't want to know what 3x's are, we want to know what 1x is on its own, so we divide everything by 3 to get x equals 12. The next question has x's on both sides, so we want to take away as much x as we possibly can from both sides. There are 7x's on the left and 5x's on the right, so the most x we can take away from both sides is 5x. So doing that, taking away 5x's from both sides, we get 2x plus 10 equals 12. Now we'd like to get the 2x bit on its own, so we want to get rid of the 10. So minus 10 both sides gives us 2x equals 2. But we don't want to know what 2x's are, we want to know what 1x is on its own. So we divide everything by 2 to get x equals 1. The next block asks us to reduce or simplify some expressions. And the first one is 2a minus 3b plus 2 brackets a plus b. Couple of things to remember here. When you see a minus, it belongs to the thing that follows it. So the minus and the 3b belong together. It's minus 3b. The minus has nothing to do with the 2a before it. Second thing to remember, when you see something times a bracket, a number times a bracket, then if you want to write that without the brackets, you've got to do the number, 2 in this case, multiplied by everything inside the bracket. So let's do that. So multiplying the bracket out, 2 times a gives me 2a, and 2 times b gives me 2b. So I've done 2 times everything in the bracket. This leaves us with a string of a's and b's, which we'd like to simplify. So let's count how many a's and how many b's we've got. We've got 2 a's here and 2 a's here. That makes 4 a's, 4a. And then we've got a minus 3b here, plus 2b here. So altogether that makes minus 1b, or just minus b. So that simplifies to 4a minus a single b. The next question is all about knowing the rules of powers, or index numbers, indices, potenser in Danish. So we've got a squared times a to the 5 divided by a to the 3. Now, first of all, you need to know that when you multiply together powers of the same thing, then the rule is to add the powers. So a squared, a to the 2, times a to the power of 5 gives you a to the power of 7, because 2 plus 5 equals 7. So that's the same as a to the 7 divided by a to the 3. And the rule when you are dividing powers of the same thing is to subtract. So that reduces to a to the power of 4, because you're doing 7 minus 3 equals 4. The next question. Well, it's a block of equations to solve. X minus 18 equals 27. So to get rid of the minus 18, we add 18 to both sides and get x equals 45. The next one, 6x equals 0. We don't want to know what 6x's are, we want to know what 1x is on its own. So we divide everything by 6 to get x equals 0, because 0 divided by 6 is still 6. And that makes sense because 6 times nothing makes nothing. Now the next one, with a fraction, these are the types that most confuse people, in my experience. 3x divided by 5 equals 15. I always like to try and get rid of the fraction first. So the fraction says divide by 5, so you get rid of that by multiplying everything by 5 both sides. So if I multiply everything by 5 both sides, then that cancels out dividing by 5 on the left-hand side. But on the right-hand side, we still need to multiply by 5, so 5 times 15 is 75. 3x is 75, divide everything by 3, x equals 25. Now the next block is a repeat of questions that appeared previously. So run through it quickly. There's the first expression to reduce or simplify. Multiply out the bracket, then collect the a's and b's, remembering that the minus belongs with the 3b, so you get 4a minus b. Next one, there it is again. Add the powers when you're multiplying and subtract the powers when you're dividing. A to the 4. Next block, December 2011. X plus 25 equals 32. Take away the 25 from both sides. X equals 7. 3x plus 6 equals 2x plus 5. We've got x's on both sides, so we want to take away as much x as we possibly can from both sides. There are 3 x's on the left and 2 x's on the right, so the most x that we could take away from both sides is 2 x's. So taking away 2 x's from both sides, we get a single x plus 6 equals 5. We'd like to get the x bit on its own, so we want to take away the 6 from both sides. So doing that, x equals minus 1. Next one. X over 2 plus 4 equals 10. Now you could do this a couple of ways. You could do it by taking away the 4 first, or you could do what I'm going to do and get rid of the fraction first. So the fraction says x divided by 2. So to get rid of that fraction, I need to multiply everything by 2. So x divided by 2 multiplied by 2 makes just x on its own. On the other side, 10 multiplied by 2 gives you 20. And then a lot of people, when they're doing this kind of question, forget to multiply the middle term there by 2 as well. So 4 times 2 equals 8. So x plus 8 equals 20. Take away 8 from both sides to get x equals 12. And you could equally well reach the same answer by taking away the 4 first and doing it in a slightly different order. The next block is from May 2012. Solve the equations. The first one is 3x equals 21. Divide both sides by 3 to get x equals 7. Second one's a bit trickier because it's got x's on both sides. 6x minus 2, remember that minus belongs with the 2, equals 4x plus 10. We've got x's on both sides, so we'd like to take away as much x as we possibly can from both sides. There are 6 x's on the left and 4 x's on the right, so the most x that we can take away from both sides is 4x. So doing that, we get 2x minus 2 equals 10. We'd like to get the bit with x on its own, so we'd like to get rid of the minus 2. We get rid of minus 2 by adding 2 to both sides. So adding 2 to both sides, 2x equals 12. But we don't want to know what 2x's are, we want to know what 1x is on its own. So we divide everything by 2 to get x equals 6. Now the next couple of questions ask you to substitute some numbers for letters. So when m is 5 and n is minus 2, then m plus n is what? So m plus n is 5 plus minus 2, or in other words, 5 minus 2, which is 3. Next one, m times n squared is 5 times minus 2 squared. It's just a question of knowing the correct order to do the calculations in and knowing what happens with minus numbers. So we need to do the power first. We need to do the minus 2 squared first. Minus 2 squared means minus 2 times minus 2, which makes 4, because minus times minus makes plus. So that's the same as 5 times 4, which is 20. The next block is from December 2012. X plus 49 equals 64. Take away 49 from both sides to get x equals 15. Next one has x's on both sides. 3x plus 10 equals 4x plus 5. We want to take away as much x as we possibly can from both sides, so take away 3x from both sides to give you the 10 on its own equals a single x plus 5. 10 equals x plus 5. We'd like to get the x bit on its own, so we need to take away the 5. Taking away 5 from both sides, we get x is equal to 5. And the next one, again one with fractions, these confuse people, and what I want to do is get rid of the fraction. So the fraction is dividing by 3x. So to get rid of that, I need to do times 3x on both sides. So if I do times 3x on both sides, then the fraction, the bottom of the fraction disappears and I'm just left with the 36 at the top. But then I need to multiply by 3x on the other side as well. So 6 times 3x makes 18x. So I get 36 equals 18x. But I don't want to know what 18x's are. I want to know what a single x is on its own. So I divide everything by 18 to get x equals 2. Now the next question, or the next block, is from May 2013. What is the value of the expression 5s minus 7 when s is 3? So it's just a question of putting a 3 in instead of an s. So 5s minus 7 becomes 5 times 3 minus 7. And then it's just knowing to do the multiplication first. So 5 times 3 is 15. So you get 15 minus 7, which is 8. And then the next question says, put a cross against the expression that has the largest value when p is minus 2. So the first one, if p is minus 2, then p minus 3 is minus 2 times 3, which is minus 6. The second one, you get minus 2 squared. Times minus makes plus, so minus 2 times minus 2 is 4. The next one, 2p plus 1, so that's 2 times minus 2 plus 1, which is the same as minus 4 plus 1, excuse me, which is minus 3. Next one, minus 2 cubed. So minus times minus again will give you a minus answer, minus 8. Excuse me again. And the last one, 1 minus 2p. So that's 1 minus 2 times minus 2. So that's the same as 1 minus minus 4. And minus minus makes plus, so it's the same as 1 plus 4, 5. So the biggest one of those is 5. Next block, solve the equations. X minus 7 is 68. Add 7 to both sides. X equals 75. 8x equals 2x plus 18. Take away 2 x's from both sides to get 6x equals 18. And divide by 6 to get x equals 3. And then the next one, 3x plus 6, all divided by 4, equals 3. So I'm going to try and get rid of the fraction and multiply everything by 4. And if I do that, we just get the top bit of the fraction, 3x plus 6. And then on the right-hand side, 3 times 4 is 12. So we've got 3x plus 6 is 12. Take away 6 both sides, 3x equals 6. And divide by 3 to get x equals 2. Okay, the next block from December 2013. 2x plus 4 is 8. Take away 4 from both sides to get 2x equals 4. Divide by 2 both sides to get x equals 2. Next one has got some brackets. When you see a number times a bracket, if you want to expand the bracket and write it without the brackets, then you need to do the number times everything inside the bracket. So to get rid of the brackets, I've got to do 3 times everything in the bracket. 3 times x is 3x, and 3 times 6 is 6. So I get 3x plus 6 on the left, 3 times everything in the bracket. So 3x plus 6 is 9. Take away the 6 to get the x bit on its own, and then you have 3x equals 3. But I just want to know what a single x is, so I'm going to divide everything by 3 both sides to get x equals 1. Now the next one, x cubed equals 27. So that means that x is the cube root of 27, the number that when you multiply by itself and by itself again will give you 27. Now that's 3, because 3 times 3 times 3 again gives you 27. There's no simple method to work these out, but they're usually, for this kind of exam, pretty low numbers. So you can, just try some numbers. 2 times 2 times 2, no, that makes 8. 4 times 4 times 4, no, that's too big, it makes 64. 3 times 3 times 3, that's right, because it makes 27. So it's only going to ever be fairly small numbers for this kind of question. May 2014, 3 plus x equals 8. Take away 3 from both sides to get the x on its own. X equals 5. 4x plus 3 equals 2x plus 15. We've got x's on both sides, so we'd like to take away as much x as we can from both sides. There's 4 x's on the left, but only 2 x's on the right, so the most x's we can take away from both sides is 2 x's. Taking away 2 x's from both sides, we get 2x plus 3 equals 15 on its own. We'd like to get the 2x bit on its own, so we want to take away the 3 from both sides, giving 2x equals 12. but we don't want to know what two x's are, we want to know what a single x is. So 2x plus 12, divide both sides by 2, x equals 6. And then fractions, again, these always confuse people, and I always like to try and get rid of the fraction first. So we've got 36 divided by x. So the fraction says divide by x. We cancel that out if we multiply everything by x. So multiplying everything by x both sides cancels out the dividing by x and leaves us with just the 36. But then we need to remember to multiply by x on the other side as well. So 9 times x gives us 9x on the right-hand side. 36 equals 9x. We don't want to know what 9x's are. We want to know what 1x is on its own. So we divide both sides by 9 to get x equals 4. Okay, the next question is another one with substituting numbers for letters. And it's all of these expressions with s equal to 2, put across against the expression that has the largest value when s equals 2. So the first one, 2 minus brackets 2 minus 5, so that's the same as 2 minus minus 3, minus minus makes plus, so that all comes to 5. The next one, 2 times 2 minus 10 is minus 6, 4 minus 10 is minus 6. The next one, minus 3 to the power of 2. So minus 3 times minus 3 makes plus 9, because minus times minus makes plus. Next one, 2 squared. 2 times 2 is 4. And then the last one, 10 minus 4 times 2. So that's 10 minus 8, which is 2. So the largest of those is 9. So we put a cross in the middle one. And up to December 2014 now, and another one with putting numbers in for letters. It says calculate the value of each expression when a equals 2 and b is minus 3. First one, a squared plus 2ab plus b squared. So that's 2 squared plus 2 times minus 3 plus minus 3 squared. Two squared is 2 times 2, which is 4. Minus 3 squared is minus 3 times minus 3, which is 9. And 2 times minus 3 comes to minus 12. So we've got 4 plus minus 12 plus 9. Or in other words, 4 minus 12 plus 9. Now when there's pluses and minus and nothing else, the only rule about what order you do them in is just to do them as they come, so from left to right. So first of all, 4 minus 12 is minus 8. So that's the same as minus 8 plus 9, and minus 8 plus 9 is 1. And then the next one, 3 times a minus b plus 4. So that's 3 times 2 minus minus 3 plus 4. Looking at the brackets first, 2 minus minus 3 is the same as 2 plus 3, which is 5. So that's 3 times 5 plus 4. Doing the multiplication first, 3 times 5 is 15, so that's 15 plus 4, which is 19. And now another block of equations to solve. First one, 3x equals 3. Divide both sides by 3 to get x equals 1. Next one has fractions. I always try to get rid of the fraction first. So the fraction is saying divide by 5. I'm going to try to cancel that out by multiplying both sides by 5. So if we multiply the left by 5, then it cancels out the dividing by 5, and we're just left with the 2x plus 3 that was on the top. But we need to remember to multiply the right by 5 as well, so 3 times 5 is 15. 2x plus 3 is 15. I want to get the 2x on its own, so I'm going to take away the 3 from both sides to get 2x equals 12, but I don't want to know what 2x's are, I want to know what 1x is on its own, so I divide everything by 2 to get x equals 6. Finally, 2x plus 24 equals 5x plus 12. I've got x's on both sides, so I'd like to take away as much x as I possibly can from both sides. There are 2 x's on the left and 5 x's on the right, so the most that I can take away from both sides is 2 x's. So if I take away 2 x's from both sides, I get 24 equals 3x plus 12. I'd like to get the 3x bit on its own, so I'm going to take away the 12 from both sides to get 12 equals 3x. But I don't want to know what 3x's are, I only want to know what one single x is on its own, so I divide everything by 3 to get x equals 4.